How? Analyze the degrees. And what does analyzing the degrees tell us? Okay, so 3 cases. Okay, which is d over d plus 1. Let's just finish this one off. What does that tell us if it's d over d plus 1? Horizontal at y cannot be 0. Second situation, degree over degree. Y cannot equal, and we call that A over B. If you don't think you're going to remember that, then just make a note. It's the leading coefficients. Third situation. Oblique, so that is y cannot equal mx plus b. And how do we find the m and the b? Synthetic division. Step 3. Calculate the intercepts. I'm not going to write down how to do that because we've been doing that since grade 10. If you need the note, then write the note. So set x equal to 0, solve for y. Set y equal to 0, solve for x. And the last step is use test points to determine the shape of the graph. And for that, we chose x values, so choose x values. And substitute to find y values. So the method box is very right-brained. Here's the exact same information in a lovely left-brain flowchart. Use whatever method works better for your brain. Us lefties like boxes. I guess, I don't know, we just like everything compartmentalized. So we start with the function, we go for vertical asymptotes first, we factor, we look at the denominator if it cancels as a whole. If there's no canceling, it's a vertical asymptote. Then we know from the number of asymptotes the shape. Then we go down to horizontal asymptotes. Here's the first, or the 2 cases for horizontal. If it's not one of those, it has to be oblique, and there's a method for oblique. Do you see why we did half of this yesterday? Right, rather than just jumping right into the graphing, and then you'd be like, what? So your choice if you like the word method, or you like the flowchart method, or you like some other method you come up with. Step number 1, factor, 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 factor. Offer of x minus 4x plus 3. What about the bottom? So this is a case we looked at yesterday, and you look and say, ooh, we can kind of cancel these. They're really kind of close to each other. So what can we factor out of the bottom to make it look like this guy on the top? The negative. And at the same time, I'm just going to reorder the terms. So I'm going to go to the negative x. If I factor out a negative, it becomes just x. And then I'll go to the 4. If I factor out a minus, it becomes minus 4. Conclusion. And where's the x-coordinate of the whole? Offer of 4. We're okay so far? What I'm just going to do is rewrite this just without the canceling there, just to make it a little bit easier. So I have that negative on the bottom, which I'm just going to flip it to the top because I don't have anything else on the negative, or on the bottom, sorry. And then I'm going to follow with x minus 3. And then I'm just going to distribute just to get rid of the brackets. So once we cancel, what's left in our function? Negative x minus 3. So the minute you have a hole and you canceled something, you want to go to this form. You want to now ignore the original question, because this is way easier to graph than the original. So whenever you have a hole and you factored and you canceled, you go with what's left. Okay, it's going to be a lot easier work than going back to the original. How do we find the y-coordinate? Well, we take the x value and we sub it in. Again, I'm going to the factored form because it's way less work. So I know x is 4. Offer of negative 7. So that means we have a hole at 4, negative 7. And the way my brain works is I actually just draw a little hole in front, just to remind myself it's not an intercept, it's not an asymptote, it's actually a hole in the graph. Okay, so this is our first graph with hole. Okay, so I'm going to come to 4 and negative 7. And I'm actually drawing a hole in the graph. Questions so far? Okay, back to our flowchart or our method. So step 2 is, okay, and we're always going back to this factored form. We're ignoring the original. Is this going to have a horizontal asymptote? No. What kind of equation is this? It's just a line. This is just a linear equation. So we can actually just graph it like a linear equation. How do you graph a line? Yes, and what do we do with m and b? Okay, and what is b for this equation? And then we use the m, and how are we going to count? So all I'm going to do is draw that line. I'm just going to skip the hole. There's your first graph with hole. We actually like graphs with holes because it always reduces, no, I shouldn't say always, it usually reduces down to a linear function, and then you don't have to do HAs. You could do intercepts if you want to, but why bother when we have y equals mx plus b? A lot less work. Done. That's it. We're done. Question didn't ask, so we don't need to. So I would make myself a note. So whenever the hole, you have a hole or something cancels, work from the factored form. So everything thereafter is going to work from the factored form. You're going to save yourself a lot of headache. Okay, so whenever you're dealing with a hole, work from the factored form. Sorry, how did I find the? So I started with the y-intercept, which is negative 3. And this we call the rise over run. So it's down 1 over 1, down 1 over 1. That's a whole unit in grade 10. How are we feeling so far? Okay. Step 1. What? No, no, oh my God, no. No, no, this is just factoring. We've done this for 3 years now. Oh, on this one. Just put an arrow swap. Can we factor the top? Can we factor the top? How can we factor the top? Hey, can we just cancel these x squareds? Why not? We don't want to kill. No, no, kill the puppies. Oh, she beat you there, Cash. The other Asian just took that from you. X minus 2, x plus 4. Confirm. Do they cancel? So what's the conclusion? They're both vertical asymptotes. The first one, x cannot equal 2, and x cannot equal negative 4. Already that tells you the shape. 2 vertical asymptotes means we're dealing with, so it's going to be one of those two, a sad clown face. I don't know why I just want to stop and draw them. I just do. Do asymptotes have to be red?
Yes.
Can they be pink?
No.
Blue?
Never.
Purple? Orange?
Not possible.
Fuchsia? Maroon? Yes, they have to be red. Red. Red.
Dark red? Or
Like if you're bleeding and need to draw them in blood, I will accept that. Yes. Step number 2, horizontal or oblique. Okay, analyze the degree, then pick your situation. So which of these do we have? Degree over degree, which means we're looking at the leading coefficients. What's the leading coefficient on the top? What's the leading coefficient on the bottom? And if you divide them, x-intercept. And then solve for x. Because we put in 0 for y and solve for x. Use some logic here. If the x-intercept is 0, 0, what does the y-intercept have to be? 0, 0. If it goes through the origin, they're both exactly the same. Or you can sub in x for 0, and you should come down to the exact same answer. Well, that's not a lot to go with. We have no idea. Is this the quadratic that's the parabola? Is it the cubic that snakes? Where are the eyes? Are they on the top? Are they on the bottom? What is going on? What do we need to do? Okay, so let's go with the inside first. Let's pick a text point somewhere in here. -2. What do we do with test points? Yep. Why are so many people yawning? What do you guys have for lunch?
I had that chicken burger in the camp.
I heard it was okay.
That was. What is the list for their chicken burgers?
The top, -2 squared. Okay, on the bottom, -2 squared. 2 times negative 2. Okay, so on the bottom we have 4 minus 4, minus 8. 4 over negative 8. Yeah, okay, so negative 2, negative a half. So we can now complete this side. We know it's got to come down and approach the asymptote. What about the other side? Is it a cubic? Does it swoop back up? Does it come back down like a parabola? I don't know either. Okay, pick a test point in here. 1. The top 1 squared. The bottom's going to be 1 squared. Plus 2 times 1. So 1 plus 2. Minus 8. Okay, so the coordinate is 1. And what the heck is negative a fifth? Yep, so if you in decimal, it's 0.2, negative 0.2. So 1 and 0.2. So do we have a cubic or do we have a parabola? It's got to be a parabola because it's coming back down. X equals negative this one? We chose it. These are test points we're choosing. Okay, what about the eyes? Well, we know they're at the top because the mouth is on the bottom, but do we know exactly where they are? Okay, pick a point. 6 is on this side. I'm going on the left first. Okay. So negative 6 squared on the top, which also gives us a 36 on the bottom. 2 times negative 6. And then we have our negative 8. On the bottom, easiest to group the 12 and 8 first, because negative 12 and negative 8 makes negative 20, so 36 minus 20. Can we reduce? Okay. 8 over 4. Ooh, 9 over 4. Where the heck is 9 over 4? Yep. Yep. Ah! So we want to correct this. Plus 12? Okay, so there's a correction. Accept, reject.
Because it's negative 6 times 2, not negative 6 times negative 2.
X squared plus 2x.
And x is negative 6. We're good? So we're good at the negative 6 and 2.5? 2.25? Okay, so negative 6, 2.25. So we know it approaches the vertical asymptote, it approaches the horizontal asymptote. So we technically do a test point over here, but I'm just going to use the fact that the graph has to be symmetric. So if this point is 2 away from the asymptote and 1 1/4 squares up, what do you know over here? It's got to be the same, so I'm just estimating where it's going to be. Again, we can do a test point, find exactly, but the graph's symmetric. So there's our first sad clown face. Are you feeling like one more, or are you feeling like stopping for today? I hear one more. With me or by yourselves? Okay. Whenever I do the factoring like this, it always reminds me of a bum sitting on a bench. Every time I do it, I can't stop looking at it. Because look, that's what it looks like. I know, now you'll be able to think about it too. That's why I'm always giggling when I do the back notes. I'm like, it's a bum on a bench. Practice, practice, practice. That's all it takes. They've been doing it for 3 years. Because you guys like quad formula everything. We factor. It wasn't easy when we first showed you. It's only because we've done it grade 9 and 10 and 11 and grade 12.
Quad formula would be like the last class, last thing, everything.
Always the first choice.
So they always do it first.
It's going to take way too long to do.
Anybody have a factoring option for us? Sorry, a little bit louder.
2x minus 3x plus 4.
There's the offer.
Yeah.
Conclusion about the x plus 2. X cannot be negative 2. Okay, horizontal or oblique. Oblique, yeah. Love it. Where do I get the numbers to go inside the division symbol? Where do those come from? I see them. Call them by name. What are they called? Coefficient of? Coefficient of? And? The constant. The constant. I asked the other class the other day, what's the name of the first method? And somebody said, method 1. Yes, thank you. Where do I get the number that goes on the outside?
X equals -2.
Yeah, so what is x equal on the bottom?
Bring down the 2.
X-intercept. So what's going to happen to the bottom? It's going to go away, so all we're left with is the parabola on top. How many ways are there to solve a quadratic? 5. We've already factored it. So this is a lot easier than what I think you think it is. Is everybody okay where those values came from? Okay, so we just set each binomial equal to 0 and solved.
Wait, what's the first quarter?
3 on 2. because it's 2x minus 3. So set it equal to 0 and solve. Y-intercept, offer of minus 6. Okay, so ignore everything with an x. We have a negative 12 on the top, 2 on the bottom. Which way does the, oh,